Chapter 11, Part 2, Introduction of Risk, Return, and Cost of Capital. So, following are the learning outcomes expected of this chapter. So far, we've seen the market for bond, stocks, and risk-free returns. We've seen risk-free returns. In this presentation, we'll explain the meaning of specific risks associated with stocks. We'll also explain the variability of returns, and we'll explain variance and standard deviation. So students are expected to understand the meaning of risks, returns, and variability. Let's measure risk first. So stocks are, we've seen in the previous presentation that stocks in general tend to give higher returns than bonds and risk-free treasury bills. But stocks also carry risk with them. And the meaning of risk is in this graph in front of you. On the y-axis is the number of years. On the x-axis is the rate of return obtained from a specific security. For example, from the top graph, we can see that stocks in general tend to give very high returns, and that can be seen here. Most of the time, the arrow is towards the right, but there are spikes on the left as well. So, for example, let's look at treasury bonds. Most of the times, treasury bonds do not give -45 to -40% returns, or -35 to -30, or for that matter, even -15 to -10% return during a year. Most of the time, they tend to give 0 to 5% return during a given year. In fact, they also don't give very high returns, 40 to 50, 50 to 60% returns, which stocks usually are also giving for a few years. But notice that stocks tend to give 15 to 30% returns on a number of occasions, which bonds don't. Bonds like to stick to 0 to 5% return range. T-bills are even more focused. Treasury bills have given 0 to 5% returns for almost 80 years. Stocks, on the other hand, have given it for only 12 years. So that's the returns from treasury bills. Now let's look at common stocks more closely. On the y-axis is number of years. On the x-axis is the returns. So very few occasions have stocks given returns above 40%, but these are finite. They're not zero. Whereas in the case of bonds and T-bills, we saw that these were zero. So there were some years in which stocks actually gave 60% returns as well. On the other hand, because stocks reward the investors so much, they also give negative returns. So during some years, stocks went down by as much as 45%. But in general, stocks give good returns at the risk that we carry them. Now for bonds, there's just 1 year in which bonds gave between 40 and 45% returns. There are no periods in which bonds gave lower than 15% returns. So that is the meaning of safety of investing in a bond. Most of the times, bond gave between -5 to +15% returns. So the conclusion is, not only do we need to know how much return we get from a security, but we also need to know what is the regularity with which we get the return, or what is the probability with which we get high returns. So that's why we need to understand the concept of variance and standard deviation. So let's play a game first in order to understand these two concepts. In this game, if we toss a coin and if we get heads, then your balance will go up by 20%. So if you had $100, you would end up with $120. If it's a tails, your balance will go down by 10%, which means if it was $100, it would go down to $90. So the coin is tossed twice, and therefore there are 4 possible outcomes. Head-head, in which you end up with 40% more. Head-tails, in which you get +20 and -10, so +10%. Tail-head, in which you end up with again +10%, -10 +20. And tail-tail, in which you end up with -20%. Both the times you lose 10%. Okay, what is the likelihood that each of this event would occur? Well, since total number of occasions in which these events can occur is 4, and we've covered all possible outcomes, each event has a probability of 1 in 4. or 25%. Now that is used to calculate expected returns. The probability weighted average of possible outcomes is called expected returns. So, like we said, each event that we described before has a frequency of 1. The maximum number of occurrences that we can have is these 4 occurrences, so each event has a probability of 1 by 4. And since the outcome of HH is 40%, the outcome of HT is 10%, the outcome of TH is 10%, and the outcome of TT is minus 20%, this can help us to calculate the expected value of returns from this double toss of coin. So we arrange this further. So since HT and TH are symmetrical, essentially represent an instance in which one tail and one head occurs, we can just club it as one single event which has a probability of 1 by 4 plus 1 by 4 or a half to occur. So the outcome 40% can only occur with a probability of 1 by 4. The outcome 10% can occur with a probability of 1 by 4 and 1 by 4, which is a half. The probability of minus 20% similarly is 1 by 4. So we essentially have 3 outcomes with sort of different probabilities of occurrences, and that is used to calculate the expected return. So the expected outcome is half times 40 plus, 1/4 times 40 plus half times 10 minus 1/4 plus 1/4 times minus 20, which is essentially plus 10 plus 5, 15, minus 5, 10. So the expected outcome is the probability weighted average of all the outcomes. Let's play the game again. Now in the first instance, if there is a HH, with an H you'll get 40%, and with a T you'll lose 30%. So with an HH you gain 80%. With the HT you gain just 10%. With a TH you gain just 10% again. And with a TT you lose 60%. So the expected outcome is, let's just arrange half times 80 plus, 1/4 times 80 plus half times 10 plus 1/4 times minus 60, which is 20 plus 5, 25, minus 15 or 10. The expected outcome of this game is the same as the expected outcome of the previous game that we played. So which game is better? Which game would you rather play? Most investors, if they were given this choice, would rather play the first game because this game has a higher risk of loss. And we can explain this by variance. Variance is defined as the average of squared deviation. Now you might wonder, what is deviation? Well, we'll define deviation as the difference of actual and the expected value. Expected value was plus 10% for both the games in the previous slide. So let's just look at the outcome, its deviation, and squared deviation now. In the first instance, it was plus 40%. That was the outcome. The expected value was 10%. So the deviation of 40 from 10 is 30%. And if you square it, it's 900. So 30 times 30 is 900. The next outcome was 10%. Its deviation from itself is 0, and the square of 0 is 0. The third outcome is minus 20%. Its deviation from 10 is minus 30. Minus 20 minus 10 is minus 30. And the square of the deviation is 900. Now why did we not just add up deviations? The answer lies in this. If we add up 30, 0, and minus 30, we'll get a net deviation, a total deviation of 0. But if we square it, then we don't really have to care about the sign. So square of 30 is 900 and square of 30 is 900. In other words, it's telling us that there is a deviation. So if we square it, add it, and take the square root afterwards, then we will get a meaningful estimate of the deviation from the mean. So the sum is 1800, and the square root of the average of 1800 is 1800 by 4. Why do we divide it by 4? Well, remember how many coin tosses, how many outcomes were possible. There was one HH, one TH, one HT, and one TT. So 4 outcomes were possible. So the average is 1800 by 4 or 450. And since we squared the deviations, now we can take the square root. The square root of 450 is 21.21. So the expected value of this game was 10% with a deviation of 21% on both the sides. So the likelihood of a 10 is high, but the likelihood of 10 plus 20 or 30% is also equally feasible, and that of 10 minus 20 or minus 10% is feasible too. So 21 is giving us a sort of a sense of dispersion around the mean. So variance, it is the sum of I occurrences from I equals 1 of n occurrences, each occurrence from 1 through n, of probability I times deviation of the outcome I squared. Now we will give this formula a meaning like this. So the outcome is 40%, the squared deviation is 900, the probability is 1 by 4. The second outcome is 10%, the squared deviation is 0, and the probability is half. The third outcome is minus 20%, its squared deviation too is 900, and its probability is 1 by 4. So what we do is, we take the first instance. The probability is 1 by 4 times its squared deviation is 900. So 1 by 4 times 900. The second occurrence has a squared deviation of 0, so we don't need to take it. The third occurrence has a squared deviation of 900. Its probability is 1 by 4, so the third occurrence also gives us 1 by 4 times 900. So variance is of the first game is 1 by 4 times 900 plus 1 by 4 times 900. That is the variance. And the standard deviation is the square root of the variance. Now let's look at the variance of the second case. Here, the first outcome was 80%. Its deviation from the expected value is 80 minus 10 is 70. The squared deviation is square of 70, which is 4900. The second outcome is 10%. The deviation of 10 from itself is 0, and the squared deviation is 0 too. The third outcome is minus 60. The deviation of minus 60 from 10 is minus 70. The square is 4900. Now let's calculate the variance using the same formula that we just discussed. So it's 1 by 4 times 4900 plus half times 0 plus 1 by 4 times 4900. So the sum of square deviation would be 9800. The average would be 2450, and the standard deviation would be 49.5, or the square root of 2450. Now you can notice that this deviation is much higher than the one that we got, 21.21, for the first game, which is why investors, like we said, since they were more risk averse, because they have a chance to make more money, but they also have an equal chance to lose more money, since the standard deviation of the second game is much higher than that of the first game. Conclusion: higher the variance, more the volatility of return. So now, can you answer which security has more variance, stocks or bonds? That's chapter 11, part 2. Thanks for listening.